Well, we're going to get started with a little harder welding here. This right here is open root. I think that material was either 1/2 inch or 5/8, and just got those tacked in there, and they got a nice torch bevel cut on them. Just showing you a little look at what I was doing, working on a disc here. It was an international disc. And this right here is where the cylinder goes down to push the wheels down, has done more slide into it. There used to be a hole there. Now normally it'd be real easy just to cut that off and weld another piece on there and drill new holes, but that was a very odd size piece of steel, and I decided to pad it up, which I'll show in a second. This right here is open root. I'm using a 6011 here to do open root with, which is it's a fast freeze rod, so you can do open root with it. If you take anything away from this video, stick welding especially, 6011 and 7018 are going to be your go-to rods. 6011 is real good for jumping gaps and doing quick tacking. It doesn't build up really fast, but it will put in a good solid fast weld, more or less. The cousin to the 6011, which is the 6010, almost identical rods. They burn very similar, other than 6011 was designed to run on AC. But just a little open root here. That's 7018 cap there. That was a filling cap. So 100% full penetration weld. You can see that the root, 6011 root in the back. I think I may have ground that out and put a 7018 in the root as well. And you can see that we cut a hole in there, and then there's the new hitch. Got a nice little quick pin there. Here's a look at the hole that I had to build back up, which this is a little tricky to do, especially how tight it is in that radius. But stick is the best choice for this. You could use other processes, but it's really difficult to wrap any other kind of process around that area. So stick's the best way to go, in my opinion. Go ahead and stick the rod a couple times. Show everybody that you're a pro. But as you can tell, as you watch me, I'll drop my hand and start welding up on the top side. And as I said before, this was a very odd thickness piece of steel. I think it was 7/8, so 1 inch would have been too big. The yoke that you see to the left on that cylinder wouldn't have fit on there, so I just decided this was a much better course of action. And right here I'm using a needle scaler to remove all the slag. Very fast, just be careful. Needle scalers will actually bury flux into little cracks if it's too tight, so just keep an eye out for that. But it's a good process, it's fast. You can tell there it doesn't take very long at all. Wow, I blew a smoke ring out just then. That's something you don't see every day. But yeah, it takes a lot of passes, and it takes a lot of metal to form that back in. It lost over 1 inch of final thickness. As you can see, I put a cap back on there all the way around. And the same thing on the other side. And then ground it all back down flush, and then cut it with a torch to the original hole size, or very close at least. And there you go, there's the pin fitting all nice and neat. It's got a little loped edges to it, but a lot better than it was. And as you can tell, I got the cylinder back together in one piece. This is I was going to show another type of padding job I had to do. This was a hitch off a field cultivator, and once again it had lost over 1 inch of its total mass, or its total thickness, and they were about to pull it in two. If they would have ran another season, I think it would have pulled itself in two. So this is a really good project as well for just turning and burning, more or less. Sit there and just burn rod after rod, more or less. Now, I'm in the shop here, I could have easily used MIG or flux core, which would have been a lot faster. But most of the time, I use stick. 90% of the time, I use stick. And the other 10% I use TIG. I use MIG and flux core very little. There's nothing wrong with flux core. I actually love flux core, but MIG, I don't know. It's good for fabrication work on light work, but if y'all ever watch my channel, most of the stuff that I do, the thinnest it goes is 1/2 inch. So I can't trust a process to do the type of work that I do. I mean, you'd have to have ungodly size filler wire to, penetrate something that thick. I'd have to run 052 or something like that. And I just prefer stick. It's a little slower, but I like it. It's what I'm good at. As you can see all the flux there on the table. I've put in a lot of passes in there. But I don't know if you can tell, but whenever you're welding something like this, it's a good idea to, after you put about 4 or 5, 6 passes in there, flip it around and start welding backwards. That way you don't get so much crater buildup. You can start lighting back up on your crater side, and it'll start stacking back up even, and you'll be left with a much better turnout. So, little tip on that. As you can tell, that's probably 100 passes, and maybe even more than that. It took me right at 2 hours, I think, to do all that. Maybe a little less, maybe just an hour and a half. Wasn't all that bad though. A lot cheaper than buying a new part, and that's what it looks like after it's been cleaned up. But like I said, you probably could have done that in 30 minutes with a MIG or flux core. So stick is definitely a little bit slower, or a lot slower. Here was one other part that I had to build up. This was a quick release on an excavator bucket, little mini excavator. It had wore probably at least 5/8 to 3/4 of an inch of slack in it. And this is something that normally you would line bore. You can see we got 2 opposing holes there, and once you got done building up what you were going to build up, you would go back in there with a line boring cutting tool and go back and just reshape the hole more or less. But as I said before, you can use other processes. I like stick. That's just me. It's simple. It's fast. Well, not fast, but it works really, really well. You get really good. You got really good control. Minimum splatter. I just prefer stick. That's just who I am. I'm going to show a little bit of open root pipe here. This is a couple of good hand positions that y'all can learn from and know how to get into those areas. Now, you see the light inside the pipe right there, actually doing a pretty good job of getting some good penetration. I get up towards the top and I hit one of my tacks, and apparently I didn't grind enough off of it, and then the light just stops. I got incomplete fusion up there towards the top. But I'm going to give you a few lessons on what not to do. You can see the light just went off right there and it comes back. So you can tell that I didn't get enough penetration right there. So I've been trying to film this for a couple of times now. The 90-degree pipe saddle, I've had a lot of requests for it. This is my second attempt, and I think it's a combination of that metal is just so old that I can't get it to penetrate like I want it to. This side right here I did really poorly on. If you notice, I'm burning right at the top of the pipe, and it's not penetrating all the way through. It's going in okay, but it's not going in like it should. Like I said, I think it's a combination of that pipe. Even though I cleaned it really well, it's just old. It's at least 25, 35 years old, and it just doesn't act like new material. It's just the way it is. Another thing I had going against me, this is 6011 rod. I should have been using 6010. They burn a lot better on pipe. That's what they were designed for. See, I got a little hole right here I'm trying to fill in, going back and forth. This is known as jacking. When you jack a rod, you move back and forth. Now this side right here I had better luck. This was the opposite side. I was actually using my left hand, which I'm not that good with. But as you can tell, I got much better penetration on this side. I'm burying that rod just as deep as I can go with it. And I actually got a positive root. Actually got to stick out a lot more than I did on that previous side. You can see it's keyholing like it's supposed to. I got a good fit. I've got a good bevel on there. This is a Schedule 80 pipe, I do believe. So you really want that rod to bury in there. You see I'm jacking it back and forth, trying to get it to close up. Now up here at the top, if you notice right about here, it starts to get a little too hot on me. I didn't feather that tack as much as I should have, and it opened up more than it closed, and I'm sitting here trying to battle it back and forth. But that was a good pass. That's something that you can take from you as a good root pass. Next thing I want to talk about is carbon arc. This is one of the most miserable things you'll ever do in the welding world, but it's good things to know about it. This carbon arc stinger right here is just giant. It's what it looks like, and it's made to accept a carbon arc rod. This is one that's pretty much graphite or carbon that's encased in copper, kind of like copper foil to help it conduct. And the trick to this is you've got little holes there that blow air out, and you want that stick out on that stick to be between 4 and 6 inches, as I'm demonstrating here, so that air is close enough that it can blow all that metal out. So carbon arc is essentially the reverse of welding. So this is all you got to have. Carbon arc has a lug right there where you plug in air and you hook your stinger to from your welder. Now, one thing I want to say about carbon arc is it's very hard on welders. It's a better idea not to use your own welder, which I did here. It's better to rent one or borrow somebody's that they don't care about. But you need a lot of amps for carbon arc. I've got it in 4th gear here, running around a little over 200 amps. So just showing you how it actually works. You can see that air is just blowing those sparks everywhere. All that molten metal is essentially doing the same thing as a cutting torch, just a lot faster and a lot cleaner. I'll show a close-up here in just a second of how well it actually does it. But it made short work of this trailer hitch here. Carbon arc is a good process. It gets hammered a lot for being so rough, which it is. As you can tell there, I had to increase my stick out. As you burn the electrode up, you have to increase your stick out. You can see I'm blowing some nice sparks at the camera. I don't think I was aware of it at the time. I thought most of them were going towards the ground, which right here I actually do. Be real careful with carbon arc. This stuff will catch anything on fire. It's raining fire more or less. And unlike a cutting torch, you can see I'm shooting it in all directions like a cutting torch does, but at least a cutting torch doesn't go 25-30 feet. But it's a good process, and it's one to keep in your handbook of special skills, more or less. This right here is what it looks like after you get done. You can see I literally cut that weld out, didn't cut much base metal, just mostly weld. And that's what it looks like after I removed it. I've already started grinding a little bit, trying to clean everything up, but I was going to show also, this here is the pigtail. You notice it's not burnt at all, and that carbon arc's a very cold cut versus a torch. This is a basic TIG torch setup. Consists of nothing more than a body. You'll have some form of cap or tail, and you'll have cup, tungsten, and any of the gas lens stuff that you need to get your gas to flow right. This one here has got one of the big styles on it. I can't remember if this one's a 17 style or maybe I'm not sure what this one is. But anyways, that's basically all it is. And then of course you'll have your tungsten, which they come in different sizes: 3/32, 1/8, 5/32, all that good stuff. Now this is a pipeline rig, and the way you can tell is the little gas valve right here. Now a lot of folks out there don't have this type of setup. They'll just have a torch that your gas will go on and off with your foot pedal. I don't have that since I do some in-field welding, so that's how this works. It's got a real nice flexible line on it, which you can see I can twist it all up and it'll go right back to normal, which that's really nice. And of course all this stuff can be interchangeable. This right here has got the long tail on it because I don't like to break my tungsten a lot of times, but I mean they come in all shapes, different sizes, anything that you could want to get into a tight place. Here's a medium one, it'll go right on there. They also have little button caps so you can get really tight, and they make shorter gas lenses so you can get really tight up in there. Little finicky places, and those are very much called upon. So, but the other thing on a rig like this one that you'll have is a welding lug. You may have to buy this separately. I think I did, which is nothing but a place for your electrode to clamp to. So you'll have your electrode and it'll just clamp straight to it, and believe it or not, that works just fine. So now the cool thing about this setup is you can run scratch start, which I'm fixing to show in just a second, or you can use high frequency start. It doesn't matter, it'll still work. So that's just a little look at all that. I've got a little lap right here I'm just gonna practice on and show you all the TIG, torch angles and everything, just to make sure. I'm gonna put 2 tacks on it real quick and then we'll go from there. I'm gonna show you a fusion tack versus a stick tack. So we'll just put a little fusion tack right here. That's with no filler wire. So I'll show you one with filler wire. Go. I'm gonna run a quick little lap here. As you can tell, these 2 pieces of material are incredibly thick. So, and run this. Now, a good rule of thumb is every time you put your wire down in there, see how it's burnt like that? It's a good idea to cut that off because a lot of times it'll get porosity right there in the very end, and all you're doing is just putting it down to the base metal. Now I'm not going to do that for this purpose because I'm just running a little quick beat pass right here, but it's always good just to cut just that end of it off. Keep you a pair of alignments nearby or some miniature bolt cutters. So let me run a pass right here. Always good if you have a foot pedal to hold your torch in place and let the argon cool the metal. There you go, not a bad pass. I didn't quite have enough heat there, that was a little cold. Something got hung up under my foot pedal. I couldn't use all the amperage. But not bad. Got pretty decent spacing in there. Now, I'm gonna reset and we'll do another little pass right here. Alright guys, I'm gonna show y'all how to set up a pipeline TIG rig since I've had a lot of requests for it. All you need is a ball of argon with a flow meter on it. Doesn't matter what kind you've got. This is a ball type. This one right here is a regulator type. Either one of them works. Doesn't matter. So we got a hose here coming off it. We got it going to our TIG line here, which has got a lug on it, grounding lug. And then we've got our ground here coming from our welder. Stick it right there. And all that set up correctly. We'll go out here to the truck. Thunderstorm rolling in. Alright, now this here is where it gets different. On most stick welding, you're going to use positive, positive, negative, negative. On TIG, you're going to have to swap them. So we'll take our positive out and our negative. Or you can just hook your ground to your lug instead of doing it the way I'm doing it. But it's really hard to put your stinger cable onto a piece to your table or ground, whatever you're using. And then you'll start your welder, and it's easy as that. That's all you gotta have. So on this, up here, I want to run with about 100 amps, so we'll go to third gear. And we'll run a little over, so about 70 on the fine tuning. So I'm gonna start ours up and we'll have at her. Okay, I'm gonna show you all the easiest way to run scratch start. TIG, that is. Okay, now on this tick torch here, that tungsten is hot right now. If I were to ground it out, it would light right up. So a lot of problems that you have when you first learn scratch start is, at least everywhere I've been taught, they teach you to touch the metal to get your arc going. The only problem with that is a lot of times it'll stick, and when it sticks, it'll break your tungsten off in your metal. And that's the issue. You know, maybe not so much when you're learning, but if there's tungsten in that metal, that's a weak spot. And also, if you're taking a test on pipe or something like that, when you go back over that spot that's got that tungsten in it, if you didn't grind it out, it will explode pretty much. That joker will get up to like 6,000 degrees when that arc hits over it, and it'll just blow up, and you'll see it'll blow all your metal out. It's very scary to see, and you'll get burned from it, of course, and everything like that, and you'll have a huge hole in your pipe or whatever that you're testing on. It's not fun. I don't like it. So the easiest way to start scratch start is to get right close up to your metal and then pull your electrode here through the tungsten. So let me give you a demonstration. Just like that. Now I'm running about 100 amps, which is a little cold on this thick of material. But as you can see, my tungsten did not break its point off because I drug it through there. Now, the second issue with that is sometimes when you strike through it, your filler wire will stick to your tungsten, and that's happened to me before, and it'll arc just anywhere, as you can tell here. But doing that, it's also a pain in the butt. You'll get arc strikes in places that you don't want them. So I'm gonna go turn the heat up a little bit on my welder so we can lay that in there a little bit better. So I'll be right back. Now there's another form of TIG out there. Don't forget to cut your ends off. There's another form of TIG out there. We've covered high frequency start and scratch start. There's also another type called lift arc, and it's much better than scratch start in my opinion, because you can hit that tungsten against this for even a full second and it won't light. You have to have contact for a little bit of time. It takes a second, so it's much better than having your tungsten hot all the time. And lift arc is very nice. As you can tell, I struck it against the vise over here by accident when I went to set it down, so it's a pain in the butt sometimes to have it hot all the time. So once again, I'll show the technique. much better. That's about 150 amps. So got a little stack of dimes going there. As you can tell, it's much better than that before. Now, one other thing, this is all beginner steps here. One other thing I wanted to show you is when you're learning to do this, it's okay to strike with the end that you're going to use and then fill with it. A lot of places won't allow you to do that because you contaminate the end of this rod. So a lot of guys, they'll strike with one end and then flip it over and use the clean end. So I'll give a demonstration of that. So there's another example of that. Ours is running good today. So just different techniques. It's just all part of it. I'll show a little bit about walking the cup real quick. I know somebody's going to ask me what's the best technique and all that jazz. So really and truly, if you can get your torch on more or less this type of angle. Now this is a really small cup. This is number 7. You really need at least a 10 in order to do this right, but it works okay. But the technique is you're just going to roll your wrist and walk a little forward each time. And try not to put too much pressure on the torch. A lot of people, they'll put a lot of pressure and they'll skid because that cup there is very slick. So learn how to feather it, just barely. All you're doing is moving your hand. It's very simple. So I'm gonna try to do a wide pass this time and watch my hand and you'll get an idea of what I'm trying to get at. So once again, strike up. Sorry about that last little bit right there. The camera got a little bit in the way and I didn't want to arc to shoot up and burn my lens. So nice pretty ripples as you can see. Well, maybe you can't see. Get that sunlight out of your face. Nice and uniform. And that's what you want. If you get your heat set right and everything's just right, it'll flow. This last little clip right here is I want to show is welding extremely thin metal. This right here is 2 razor blades and they're 20 thousandths thick, so extremely thin. You can see where I burned through right there trying to test how far I could go with my amperage. But one thing I want to show is this filler wire is way too big to weld these razor blades together. You can see that that's about 4 times as thick as that razor blade is. So what do you do? How do you weld this? Because your filler wire is not going to melt and your razor blades are. So what you can do is get you some MIG wire. That's what I've got over here. This is the exact same stuff as TIG wire. If it's not, it's only off by just a little bit. There may be more silica in the TIG wire, or there might be just little aspects of it. If they're not the same, they're very, very close. But I just want to point that out. If you ever have to weld something extremely thin, that it's totally doable. You just got to have the right stuff, more or less. So that's just one thing I wanted to point out. This is the technique of using MIG wire to actually TIG with. If you can see it there on the right. What I was trying to do here is I had a broke off tap in this part. Somebody broke off in, and I was trying to build up some metal on it so I could weld a bolt to it so I could pull it out. And using MIG wire is very good for, like I said before, for really, really thin metal. And the bolt that the tap that I was trying to pull out was a 1/4 tap. It was tiny. You know, they're fairly small. And this is high frequency start that I'm using. You can tell I'm trying to jump the arc. If you're using scratch start on this, it would be just incredibly difficult because you would just arc all over the place. With high frequency, at least you can put it right exactly where you want it. But this here is a good technique. You can also use stainless MIG wire as well if you had to weld to stainless, of course, or any other alloy. Stainless really takes good to cast, and a lot of different we all always called them bastard metals. You didn't know what they were made out of. But I'm going to speed this clip up here so you can actually see what I actually did. But that's probably going to wrap it up for this video, guys. I hope you enjoyed it and hope you get something out of it. Please like, subscribe to me if you hadn't already. And guys, I will see y'all next time. Enjoy the rest of the clip.